To show you how that gravitational equation works, I'm going to solve this problem. Problem 1, chapter 1, problem 5. We have two spheres here. One of them is titanium and the other one is copper. And the radius of both of them are given. For this one is R, and R is 40 millimeter. And the other one is 2R, so 80 millimeter. And you can find the density of these two titanium and also copper from the tables at the back of your book. It is slightly different than if you Google them. So use the tables of the book. And we know the distance between these two as well. And the question is asking about the force, the gravitational force that titanium is exerting on copper. So it is asking about this force. If I call it F. We are going to have the same force on titanium as well, right? But titanium is applying this force. The direction of this is going to be in opposite of this one. The magnitude of this force, you can find it using gravitational force equation, m of titanium times m of copper divided by the distance between these two squared, so 6r squared. And g is given. To find the mass of these two, you need to multiply the density of these two to the volume of them. The volume of a sphere is 4/3 of pi r cubed, right? So for titanium, it's going to be rho of titanium times 4/3 pi times r cubed. And for copper, you need to find the density of the copper from the tables of the book. Then the volume is 4/3 of pi times the radius of the copper is 2r, so 2r cubed. Rho of titanium, let me write it here, is 4510 kilogram per meter cubed. And rho of the copper is 8910 kilogram meter cubed. Okay, you can find the masses of these two, then put them back in this equation to find the force. If you do that, F is going to be equal to 2.68 times 10 to the negative 8 Newton. Be careful with the units. R is given in millimeter. You need to turn it to meter, right? So R is going to be 0.04 meter before putting them in these two equations. So this is the magnitude of the force, but the question is asking about the vector. We need to find the direction of it too. So you need to multiply F to cosine of this angle, which is 35. In negative I direction, that's going to be the I component. And the J component, you need to multiply F to sine of this angle, which is going to be in negative J direction. So F as a vector is going to be 2.68 times 10 to the negative 8 times negative cosine of 35 in the I direction, negative sine of 35 J direction. This is the direction of the force, right? Magnitude of the force times the direction of the force. And if you calculate those sine and cosine, it's going to be negative 2.19 I and negative 1.535 J, both of them are negative, times 10 to the negative 8, and the unit is Newton.